This is a quick recap on fractions and what you should know so far, and going into all the normal things you would do with a fraction. So fractions, let's start off with, what is a fraction? Well, a fraction is some amount divided by another value. The top number we call the numerator. The bottom number we call the denominator. It can also be called the divisor, but generally we talk about numerator and denominator. These are not numbers that will, not words, that will come up to explain numbers in the test. You will not be asked to memorize these, but I would ask you to try and remember that the denominator's on the bottom, the divisor, the thing you're dividing by, is on the bottom. Now, another way to think about fractions is as a division. We have something, I'm going to call it A, divided by something else, I'm going to call it B. This symbol in the middle is just telling us what happens where. So we'll sometimes see it written as A divided by B, like that. That will generally show up in Word documents rather than anything that you would see in a textbook or on an exam though, just because the divide symbol is not an easy one to find in your standard keyboard. Right, as you can see from that layout, however, the A, because it comes before the divide, and the B, because it comes after the divide, tell us which is which. So we have A over B. Okay. Whenever I'm talking about general mathematics and general information, I will tend to give you an algebraic form. Try not to let that scare you. Algebra is just shorthand. It saves us from having to try and explain things. If we use just numbers to explain things, then you can get tied down to what a value might mean. Whereas algebra just means it could be something, and this rule always works. So we've got something divided by something else. So to give you a little example, if we had 3 divided by 4, if you stuck that in a calculator as 3 divided by 4, you get 0.75. So you can always do top divided by bottom to get the decimal value of your fraction. One of the other things you could do is have a fraction of an amount. Let's say 40. Okay, when you have a fraction of an amount, of in maths is a times, out of is a divide. So we might also call this out of. So 3/4 of 40, I can replace that word of with a times. Now on a calculator you could do 3 divided by 4 and then times it by 40. A little bit of rearranging, and we could also have the same thing as, so we could have 3 divided by 4 and then times 40, or we could do it as 3 times 40 and then divide by 4. The order that we do these in is called commutative. It doesn't matter which way round we do it, as long as the bit that's doing the dividing is always the bit on the bottom. Either of these would make an easier calculation. What you're going to come to discover is that we can even cancel down and make the sum simpler with a little bit of what we call equivalence. So if I'd written it as 3 times 40, all divided by 4, I can say, okay, 40 is the same as 3 times 4 times 10, all divided by 4. Now I have a 4 on the top and a 4 on the bottom. And I can cancel them out. And that gives me my answer as 3 times 10, which is 30. I've just realised I wrote that out of the screenshot. So we've got 3 times 10, which is 30. Right. That's your basic how to use a fraction. We have fractions that are giving us the instruction, top divided by bottom. We have fractions that are giving us an explanation of what we're looking for, a fraction of an amount. The next step is things we can do with our fraction. Okay, so I'm going to take this off. Ooh. Right. If we have the fraction 1/5, I can scale that up or down. Now, scaling it down doesn't make much sense when you've got a 1 on the top. We like to try and keep our numbers whole numbers, natural numbers or integers. We try to avoid fractions of fractions and decimals in fractions. It's not always possible, but in general you will find them to be whole numbers. If we have 1/5, we could also write that as 2/10 or 3/15 or 4/20. I'm going to display this, and this is where I regret not having graph paper. So if I have, you're going to get one of my terrible drawings here. 1, 2, 3, 4, 5. If I have 5 boxes, then you can see that one of them is 1 out of 5. If I split them up, if I split them all into 2, you can see that that 1 of 5 is the same as 2/5. 2/10, sorry, because I've now got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's the same as 2/10. I'm going to stick with the black actually. Now thirds is going to be a hard one to draw with what I've done, so I'm not going to go into that one. The 4/20, if I break these up further, I've now got 20 blocks, and you can see that 1/5 is 4 of them. So it's the same as 4/20. Okay. This is called equivalence, and we use it to simplify our maths as well as to expand outwards to make things easier to work with. A lot of maths is about manipulating the numbers and manipulating the formulas to give you a simpler calculation to work with. So that's the basics of equivalence, and we're going to use that. Now, before you can add or subtract a fraction, you need to have the denominator the same. So if I have 1/4 plus 1/3, before I can add these together, they need to be the same thing. I'll show you what I mean. If I have got, I will try and draw circles. If I have got 1/4 and 1/3, so I've got this one and this one, you can see that 1/3 is bigger than 1/4. It's because it splits things into less pieces. The more pieces you have, the smaller the pieces will be. So as these numbers on the bottom get bigger, the things that it represent get smaller. Now if we're to add 1/4 and 1/3, you can see that a third is bigger, so we're adding things that are going to get us a bit bigger than taking it to the half. But how much bigger? Well, in order to get that, I need to work out how many pieces I need before I've got my diagram to show me things equally. So on this side I've got fourths and on this side I've got thirds. So I want to try and find some times table where they meet. So if you look at your 4 times table, and I realise a lot of you are going to have worked this out instantly, and I do my 3 times table, I'll keep going to there. Oh. Right, I can go to there as well actually. Right, we're looking for places where they meet, and I realise I missed 6 as well. This is going to happen a lot through the course. My brain's going on ahead of where I need to be and I will miss things. Just pull me up on it. So the first time these 2 times tables meet is number 12. The next time they meet is number 24. You always want to go for the smallest number if you can. Right, okay. So if I make our quarter into 12ths, how many pieces out of 12 will we have? Right, well, let's have a little look. So to get 12, we've got 4. I need to split it up three times. So I've got 3 of them. That doesn't show up very well. 3 of them from my original quarter. And the rest are blank. Now the way to think about this is, what did I do to get the 4 to be 12? I timesed it by 3. So I've got to do the same to the top. And to get this 3 to be 12, I've also got to times it. So 3 to 12, we're timesing it by 4. So that's 4 on the top because it's 4 times 1. Okay. Another way to think of this would be called the cross and kiss method, but I'll show you that when I've shown you a couple of other bits. Okay, so that's the basics. Now we've got them the same, we can add them together. And because we're working with pieces out of 12, our 12 stays in our answer. So when you're adding together or subtracting fractions, once you've found your denominator, it stays for your answer. You don't change it again, you don't add it. 3 plus 4 is 7. Right, and okay, 1, 2, 3, 1, right. So you can see I've got my 4 pieces there, so that 4 and that 3 gives me 7. Okay. Keep moving this board. I'm not sure it's still in the frame. Right. Okay. Now, if we've got something a little more complicated, like 2/3 plus 4/5. Now I'm looking at this one, I'm going, okay, the first time these times tables are going to meet is when 3 times 5. So that'll be 15. So on the bottom, I'm looking for 15. My answer will be out of 15. So you can always multiply your bottom numbers together to get you your denominator. Sometimes it's not the best thing to do, and I'll explain more in class, and we'll practice more in class about that. You want it to be the smallest number that comes in both times tables. So 3 times 5 gets me 15, so I need to do 5 times 2, so I get 10. 5 times 3 gets me 15, so I need to times the top by 3. 3 times 4 is 12. 10 plus 12 is 22. This brings us into another thing. Here we've got what's known as an improper fraction. We'll go with that colour. Improper fraction, or top heavy. Now you can leave your answers as top heavy fractions. You certainly won't lose any points for it. But if you want to make it something a little more manageable, a little more user-friendly to the general population, you can change it into a mixed number. And you will sometimes see things given to you as a mixed number in the exam, and you will have to convert them into a top-heavy fraction in order to use them going forward. So how many 15s go into 22? We have 1 whole 15, and that leaves us with a remainder of 7. And that 7 stays on the fraction. So another way of thinking of fractions can be to think of them as a traditional division. So we had 15 going into 22, and that gave us 1 whole 1, which is 15, with a remainder of 7, and that 7 stays over the 15. Okay, this is one of the few times you're ever going to see me use this method. I only use it to demonstrate. I personally don't like it. Okay, so that is addition. Subtraction is dealt with the exact same way. Top-heavy numbers, changing them into mixed numbers. So before we go on to multiplication and division, I'm going to quickly go over mixed numbers into top-heavy numbers. So let's start with our mixed number. Let's say we have got 3 2/5. What you're going to do is say, okay, this represents 3 whole things and 2/5 of something else. So we want everything to be out of fifths. So how many whole lots of fifths have we got? That sentence might have confused some of you. So if you think of it as 1, 2, 3 full circles and 2/5 of a circle. Okay, that's not a very good fifth, but you know, it explains what we're talking about. So we've got, if we split these into our fifths, yeah. So you can see there we've got 3, so we've got 5, 10, 15 plus these 2, which is 17. The easiest way to think of it is multiply these together and then add that. So 3 times 5 is 15 plus 2 is 17. Okay. Right, this is a whirlwind tour. If you want more practice, there's plenty on the Google Classroom. So I'm going to move on now to multiplying. So when you add and subtract a fraction, you have to make your denominators the same. That does not follow with multiplication and division. It does not track through. So if we had 3/4 times 3/5. What we do with multiplication is straight across. So you're going to do 3 times 3 on the top and 4 times 5 on the bottom, which gets us 9/20. Okay. Now, in class, you're going to see in some of the practice sessions that we're doing that you can cancel down. Not in this particular example, but if it's possible for you to cancel down before you multiply through, you really should do it. It makes your numbers more manageable. So if I'd had, instead of that one, if I had, let me think of one. Stick with the threes. 3/5 times 2/3. Here you can see I have got 3 on my top row and a 3 on my bottom row. They can cancel each other out. So I end up with 2/5. Okay. If you've got the same on the top and the bottom, you can cancel them when you are multiplying everything. There are exceptions, and those of you going on to the Nat 5 Pure Maths course will get a lot of practice with the exceptions. If there's brackets involved, you need to move whole brackets, not parts. Right. But if it's multiplying the entire top and multiplying the entire bottom, you can cancel it. Now to move on to division. If we have got a fraction divided by another fraction, and it doesn't matter what they are. Can't believe what I've just said. Never mind. Right, here we've got 2/3 divided by 4/5. Now in reality, that means you've got something that's 2/3 of a shape. Right. And you're then dividing that shape further into 5 and 4 of them, which is a complex thing to try and think of. Fortunately, we have a formula for this. We call it the flip and multiply. So you take your first fraction, it stays as it was. You flip your second fraction upside down and you multiply. Multiplying is easy. You've just seen us do that straight across. 2 times 5 is 10. 3 times 4 is 12. Now, this is why I talked about simplifying. That answer would not be acceptable because top and bottom are both in the 2 times table and can be simplified. It'll get you most of the points, just not the final point. What you need to recognise here is that we've got a 2 and a 4, and a 4 is the same as 2 times 2. So that 2 can cancel with one of those 2's, and we end up with 1 times 5 on the top and 3 times 2 on the bottom, which is 5/6. If you had done this version though, you have one final step to do. You need to recognise that they're both even numbers, and when they're even numbers you can always half them. So half of 10 is 5 and half of 12 is 6. So I get the same answer, 5/6. Okay. Now I'm going to leave it there for that video, and hopefully if you've any questions you'll contact me and we can discuss them. Thanks.